Hi everyone. So as we already know, Google processes petabytes of data every single day, right? But here's the crazy part. Instead of relying on super expensive machines, their file system is built on ordinary servers that often fail. So how does it stay fast, reliable, and scalable? Right? Welcome back to the Google File System series. Today we are going to uncover its architecture. So in part one, we already talked about why traditional file system couldn't keep up with the Google scale, right? In part two, we'll explore how Google file system is structured, that is master, chunk servers, and clients. And we'll also see how its core idea, that is chunking, powers scalability, fault tolerance, and efficiency. Plus, we'll walk through how data actually flows inside the system. To recap, GFS was designed with four big goals in mind, right? First one is scalability, that is to handle thousands of machines and petabytes of data. Second, fault tolerance, because when you use cheap commodity hardware, failures are the norm and not the exception. Third one, optimized for large sequential reads and appends. Since most Google workloads involve big log scans, crawling, indexing, etc., optimizing for large sequential reads and appends was one of their requirements. And last but not the least, simplicity with efficiency. So engineers could build fast without battling the file system itself, right? Now, before jumping into the architecture of Google file system, we need to understand the core idea behind it, right? And it's called as chunking. So, what exactly is chunking? The idea behind chunking is to, instead of storing a huge file as a single block, we can split that file into a 64 MB blocks or chunks, right? And store them separately. This 64 MB size is much larger than what traditional file system uses, that is of 4 KB or 8 KB. Right? Question is, why does this matters? uh, First point is, we have less metadata to manage, right? A single 1 GB file would have only 16 chunks, right? And since 1 GB file is only having 16 chunks, master server has a very less amount of metadata to manage and hence less bookkeeping to do, right? Second point, efficient and large reads. So workloads like scanning web data or training search indexes benefit from reading fewer and larger blocks at once instead of reading either one big file or small 4 KB blocks in traditional file system, right? Next point is fault tolerance. Each chunk is replicated across multiple different chunk servers, right? So if one of the chunk server fails, or let's say data gets corrupted, that chunk particular gets corrupted in that server, we can easily fetch data from another chunk server, right? And the last one is selective access. So clients don't need the whole file to read a part of it, right? I mean, assume that you have 10 GB file, but currently you want only a smaller mid portion of it, right? So client can request exactly those chunks and use it instead of getting whole file at once. So this saves bandwidth, memory, and time. You can think this particular idea as splitting a giant book into multiple small chapters instead of keeping it as one giant scroll, right? And you can jump to the exact chapter you want while still keeping backup copies safe on their shelves. At the center of this whole system sits the master server. It doesn't store data chunks itself. Instead, it's systems librarian, you can think it as, right? That is tracking metadata. So what does it track? It tracks which chunks belong to which file, where those chunks are located, and which chunk server holds the primary lease for writes, right? The master is critical, but it avoids being bottlenecked by only handling metadata, not heavy data. So next component in the system is called chunk servers. These are, you can think it as these are the shells holding the actual chapters or chunks of our massive digital books, right? So each chunk server stores chunks on local disk, and each chunk is replicated across multiple servers. So in one shelf, you don't, if one shelf collapses, you don't lose the book. Other shelves have the same chapter. Finally, the last important component of the overall Google file system is called as client library. This is linked to Google applications like search, Gmail, etc. Right? So when an app needs the data, the client library first asks the master for metadata, right? Then master tells in which chunk servers those particular data will be present that client is looking for, right? And after that, client library would directly talk to the chunk servers to fetch or write the data, right? The design keeps master lightweight and ensures that fast and parallel data transfers are happen between chunk servers and client library directly instead of involving master. Okay, so now that we have gone through major components of the system, let's try to understand how these components work together, right? So there are primarily two flows. One is called control flow and one is called data flow. So control flow involves, what is control flow? Control flow basically means flow that doesn't involve the data directly, right? You can think it as the flow to figure out where a particular chunk is located, and or maybe if you want to write the chunk, where a particular chunk should be written, right? How does this control flow works? The client asks master that, hey, this is the chunk number. Can you return all the servers from which I can fetch this particular chunk? The master would check in its metadata database and would return the list of servers that holds that particular chunk, right? Now, and after that, master steps aside. You can think this as you going to librarian and asking that, hey, I want Harry Potter part 2. Then librarian would tell you the list on the location of shelves where this particular book is present. So now let's go through the data flow, right? So data flow is the flow that involves data directly. By this, I mean this would flow. This would be the flows where you would read the exact data or you would try to write the data, etc. Right? So how does this flow works? So client sends data directly to the all chunk servers holding replicas, right? Uh, here by so here master doesn't come into picture, right? You can think this as client directly communicating to the chunk servers, and let's say if one of the chunk server is not having data or the data is corrupted, let's say, right, the client can directly itself request data from another chunk server because master has written him the list of chunk servers. Okay. So you can think this as that the library has given you the locations of the shelves from which you can fetch that particular book or chapter of the book, right? And now you're directly going to those shelves and fetching book by yourselves instead of involving master and or librarian and asking them to please give me this particular book. So why this particular high level architecture works, right? So this particular design gives Google file system three superpowers. First, scalability. Big chunks reduce the metadata load, and direct client to chunk server paths let thousands of clients work in parallel, right? Next one is fault tolerance. So because we are replicating these chunks, and it so if one, as I mentioned earlier as well, if one chunk server fails, we can fetch from another replica, right? There is also heartbeat communication between master and chunk server, automatic re-replication that makes the system more reliable and self-healing, right? And last one is high throughput. So workloads like crawling, logging, indexing run smoothly because clients read large chunks of data directly from the server instead of bottlenecking master server. So yeah, that was it about in this part about the high level architecture of the Google file system. In the next part, we'll try to go through more complex parts. That is, we'll try to dive deep into how exactly read and write flows work, what are the failure scenarios, how file system handles them, what are the consistency models, what are the recovery models. If this breakdown helped you understand the Google file system better, hit like, subscribe, and share it with your friends. Let me know in the comments which system we should break down next. Thanks for watching. Also, I've written a blog post on this particular topic. You can go through it. There are multiple other blog posts as well on different topics. Please go through them and let me know your thoughts. Thank you so much.